Good morning, everybody, and welcome back to Next Door NetAdmin. Last week, I talked a little bit about first hop redundancy protocols, including HSRP, VRRP, and CARP. Today, I'm going to walk you through what some of the configuration for HSRP looks like. Again, HSRP is the hot standby router protocol. It is proprietary to Cisco devices, so that admittedly makes this a little less useful for any of you using devices that are not Cisco devices, but they happen to be the devices where I have set this up most often in the past, so it's the easiest for me to show to you. And you'll still probably see a lot of recurrent concepts in the configuration of this that are definitely reused in VRRP, and as far as I know, also reused in CARP. All right? Cool. So, what does this look like in what does this look like in the first place? Anyway, here is an example of how you might see HSRP set up, and I'm going to break this down for you in each line. First off, you're wanting to configure this on whichever interface has the IP address that you want to have standby operating on. If that's a VLAN address, then you'll put it on a VLAN interface. If it's a physical interface, you'd put it on the physical interface. That's fine. This happens to be on a VLAN interface. The device itself, whether this is a router or a switch that's doing routing, doesn't matter. The device's IP address on this interface needs to be something different than the IP address you want to have as standby, because the standby address is going to be a virtual IP. So you don't want to configure it as the actual interface IP address. So in this case, this device is going to be 10.0.0.2. Then I'm going to configure it with a standby address of 10.0.0.1. Let's go back up here. Standby version 2. HSRP has two different versions. By default, it'll use version 1. Version 2 adds some more enhancements. It adds support for more standby groups. And rather than sending messages to all routers, it sends it to a different multicast group that honestly I don't recall the name of right now. It's not terribly important, but it restricts the multicast group that it sends to. And since it offers support for newer enhancements, newer features, I prefer to use version 2. It just seems to make sense to me. Standby, this 10 is the group number. And most of these commands, other than the version, use a specific group number. So for standby group 10, we're using IP address 10.0.0.1. Cool. Standby 10, group 10, priority 110. By default, the priority is 100. If all your devices, or both of your devices, if you've only got two, are using the default priority, the active router will be determined by which router has the highest IP address. So if I have 10.0.0.2 and say 10.0.0.3, dot 3 would have the highest default priority because it has the highest IP address. But maybe I don't want that to be that way. Maybe I want it to be statically configured with one device should be authoritative, the other device should be standby. In that case, I can set the priority manually, but the default priority is 100. Standby 10 preempt. Preemption is a concept where by default, HSRP does not want to shift which router is active unless it has to. If a router drops offline entirely, then obviously the standby is going to step in and start taking over service for that device. But what happens if it's still online? It's just a fact that the priority level changed. If it's just the fact that the priority level changed, HSRP will not, by default, change which device is active. And this priority change could happen in a number of ways. A little bit further down here, we're going to see that we can change the priority by linking it to a tracked object, but this also takes place if the administrator goes in. Let's say it's not going through the right device, you're looking at your configuration and you're going, oh, I forgot to configure a priority. Let me just configure that priority now. Boom, now this device has a higher priority, it should take over. It's not taking over. What's going on? I just made it the higher priority device. That would be because it doesn't have preemption enabled, and so it will not take over. Similarly, if you're using this tracking command and it decreases the priority, that doesn't necessarily mean that the other device takes over, unless the other device has preemption enabled, and then it can say, oh, wait a minute, suddenly I have the higher priority, I need to muscle my way in here and take over the route. So preemption, kind of important to have in order for things to work the way you would normally think they work, but it's not there by default. So you need to make sure that you have it configured. Standby group 10, authentication. By default, all HSRP messages are authenticated in plain text. Yeah, plain text. They're authenticated with a plain text of Cisco. Not particularly a secret value, not particularly hard to guess, and not particularly secure. I would go so far as to say not secure at all. So you can set it up with authentication with a different clear text password, which, being that it's clear text, also offers basically no security. Anybody worth their salt with a packet sniffer can find out what your text message is. Cool. So the other option that HSRP offers is MD5 hash authentication. Is it as secure as I would like it to be? No. Is it better than clear text? Yes. And the key string, you can put whatever password you want in there. Cool. That becomes the key string with which your HSRP messages will be hashed. Now, here's an important point to note. Unless you have password encryption enabled, when you type this password in, it will remain in clear text in your configuration file. It'll be used as an MD5 hash when it's being transmitted over the network, but it will save it in your configuration file as a clear text password. If you do have password encryption enabled on your Cisco device, then when you look at it, you'll have keystring 7, and then you'll have a Cisco type 7 encrypted password here rather than a plain text value of a password. But as I've covered in the past, type 7 encryption itself is not very secure, and you can use publicly available tools to decrypt it. So it's more obfuscation than it is actual security. Be that as it may. Again, just like with MD5 hashing, it's a case of it's better than nothing. So if you see keystring 7 and a random string, it's not secure, but it's better than nothing. All right, and then standby 10 name, main gateway. This is just a name. It doesn't have any particular importance other than to you, the administrator, because when you look at your configuration, it's easier to see what it is. And when you use debugging commands like show standby, it'll tell you what the name of the group is, and you've got a better idea of what you're looking at, which is a good thing. Standby 10, track 1, decrement 30. What does this mean? Well, standby 10, standby group 10, is tracking object 1, and when that goes down, or when it is considered down, it'll decrement the priority by 30. So it'll drop from 110 to 80. Okay. I've covered in the past how you can use IP object tracking. That's what this is. IP object tracking, you have a track number. That is the number. This just says, I want this HSRP group to track this object, and it'll decrement the priority. But again, that will not change your active router unless you also have preemption enabled on your partner device so that it can take over. Conversely, let's say your group comes back up. Yay! It'll go back from a priority 80 to a priority 110, but it won't take over unless you have preemption enabled on this device. So yeah, preemption is laden with possibilities for things to not work the way you think, so long as unless you make sure that you have it enabled on both devices. Now, what's all this? Standby 11. This is just me demonstrating that you can have multiple HSRP groups on a single interface. Let's say you've got a main gateway address. Okay, cool. But then you want another IP address for another purpose, which will float between routers. And in this case, I've given it a name of routing target. Here's an example of what I mean. I have had 3 separate routers, all of which are on the same VLAN. So all 3 of them share the main gateway address. But I also wanted a specific address for just routers A and B, and I wanted another specific address for just routers B and C, and I was sending different routes to those targets. So in that case, if router B goes down in the middle, okay, well, I know which one of A or C is going to be my main gateway, but if I have routes that need to specifically go to one of A or B, I need that to go to A. It can't follow the main gateway priority because that's for internet traffic. So I've had individual interfaces with 3 HSRP groups, all with different virtual IP addresses. Is it something that people should expect to see a lot of? No, but it can be done. These kinds of redundancy protocols are not one per interface. They're as many groups as you need per interface. Standby 11 has the separate IP address. It does have preemption enabled. It has MD5 authentication with a different key string because you're authenticating different messages for a different group. It has a different name. This one is tracking an actual physical interface. And because it's tracking this interface, it's not tracking whether the link is there or not. Specifically, it's tracking the line protocol. Do you have a valid protocol operating on that line rather than physical status? Fun fact, if it is a removable interface and you remove the interface while it's tracked, HSRP will just say it's down and you cannot untrack it until the interface comes back. So Cisco's documentation says if you're tracking a removable interface, you better make sure that you untrack it before you remove the interface. Otherwise, your life is going to be difficult. And in this case, we don't have a separate priority command for standby group 11. That means it's using the default priority of 100. And if our tracked interface goes down, it will decrement the priority from 100 to 80. You could type in standby 11 priority 100, but because that's the default value, it will not show up in your configuration file. So this is where the knowledge of your default values becomes important. With a Cisco device, if it's default, it's not there. You just have to remember it. Or try and remember to type it manually into your configuration when you pull it out so that you remember what it is. All right, cool. That's all of that. What's it going to look like on your partner device? Let's bring another device's configuration online here. Online. So, same VLAN. Here's your partner device at 10.0.0.3. Different physical IP address, but it's going to share the same virtual IP address. Has to be using the same version, standby version 2. Standby group 10, here's your IP, 10.0.0.1. I do have it set to preempt so that if this one goes down, this one will take over. When this one comes back, this one will take over. Just make sure that you keep them in sync. Really, it's annoying to have to deal with if they get out of sync. Your MD5 authentication, it has the same password, it has the same name, cool. This one is tracking another object, track 1. That's object 1 on this device, not object 1 on this device. I could just as easily have this track 102. If I have a different IP object on this device named 102, I can have standby group 10 track that one on this device and track group 1, object 1 rather, on this device. It doesn't matter. I could change the decrement so that it decrements by 15. In this case, I want it to just decrement by 30 because I want to keep it consistent between these two devices. No no standby priority for group 10 on this device. Again, that means that this device has a priority of 100, which means under normal operation, this one with priority 110 will be the owner of 10.0.0.1 until it goes down and the priority becomes 80, and then this one will take over as priority 100 because it's got preemption. For standby group 11, this is the IP address 10.0.0.100. This one has standby 11 priority 110, which means for group 11, under normal circumstances, this device will be the owner of the virtual IP 10.0.0.100, and this one will be 10.0.0.1. Standby 11 preempt, authentication, still MD5. It's a different password. It's tracking the same interface. It could track a different interface. It wouldn't matter. And it'll have the same decrement value so that it'll drop its priority by 20 if the tracked interface goes down. You could keep going through many different VLANs. You could go through many different interfaces. And this is very powerful. There is some note that every object you track does consume some CPU resources. So not every interface has to be using a redundancy protocol. Use it where you need to. Use it where you have a use for it. Don't feel a need to go ham with it. But it's a useful tool in your toolkit in order to make services a little more redundant, a little more survivable. You can configure your endpoint workstations with a gateway address of 10.0.0.1. And if one of your routers dies for whatever reason, the other one will step in. Your clients don't need to know anything about it. They'll just keep using 10.0.0.1, and they have no idea it's going through a device with a different physical IP address. So that makes it really useful. And these interfaces behave much the same way. You could configure an IP helper address, which is what you use for directing packets to services that are on a different subnet. So for example, in this case, I'll say IP helper address 10.1.1.10, which means, hey, if you hear a DHCP request, forward it to 10.1.1.10 on a different subnet. If you hear a bootp request, the predecessor to DHCP, send that along. There's actually a list of about 8 different services that a helper address will forward for. And you can have multiples of these. You could have a backup DHCP server or a proxy DHCP server for PXE boot services, and you can have that on a different subnet. You can have that on a different IP address. In the same subnet, it doesn't matter. You can have multiples of those. But that only works on this device. So if this device is 10.0.0.1, cool. If it gets a DHCP request or a PXE request, it will forward it to those devices. But if this track goes down and the priority becomes 80, this one takes over. Where does the forwarding go? Again, you'll have to make sure that you take those commands and you implement them on your secondary device. So your first hop redundancy does not necessarily make sure that the rest of the services configured are in sync. It's just for the standby group IP address. And you still need to make sure that you configure both devices separately with whatever firewall rules you need, or helper addresses you need, or anything that is going to be tracked per device. One thing I mentioned last week was that one of the reasons that the BSD folks spun up CARP was so that it works in tandem with PF sync, PF being the packet filter in BSD. And so PF sync can synchronize firewall rules between devices. Here's another fun fact. Your secondary device does not even need to have the virtual IP defined. It doesn't have to. If it's configured with anything for standby 10, it will start listening on the network for messages from standby group 10. And it will learn the standby IP address from another device on the network. I would never do that. I would never leave this one without the standby IP address configured, because I want to be able to see it specifically and remind myself, hey, standby 10, not only am I telling myself it's the main gateway, I want to tell myself what the IP address is as well. But there is some flexibility there in exactly how you do it, and it will try to make something work. But as a good network administrator, you really should try and make sure that you configure it as much as you can explicitly. All right, so yeah, that's the basics, I would say, of HSRP. I'm sure that there's more things that you could do. Remember that VRRP uses a lot of the same concepts, such that Cisco originally started waving their patent on HSRP around and saying, by the way, we have this patent, and but fine. It uses a lot of the same principles. Some of the commands will be different. In fact, pretty much all of the commands will be different. But VRRP is theoretically cross-vendor compatible. So you may have situations where you're using a non-Cisco device and VRRP is a good solution. Or if you're using all BSD devices or Linux or whatever else has had CARP ported to it, you might use CARP instead. The choice is yours. But this gives you a general idea of how these protocols will work and some of the considerations that you might run into in trying to configure them. So that's pretty much all I have for you today. As always, if you have thoughts, questions, comments to be made on the content of this video or on the content of other videos yet to come, i.e., if you have ideas on what you want me to talk about, tell me. Let me know down in the comments section. That's what it's there for. I don't know why I phrased that so weird, but there it is. And otherwise, hopefully, this was of use to you, or it was illuminating or an interesting look at to some of the things that a network administrator considers. Otherwise, thank you all very much for watching. I am your next door administrator. I am your next door net admin. That's what I am. And we will see you all next time.